Hello, my name is Marco. I am the founder of Fierro Labs and Fierro API. Fierro is a web API implemented in Go that enables developers to create, publish, republish, and track IPNS records. In other words, it's an IPNS pinning service. So in today's demo, we're going to be going over some of the key features that Fierro has. More specifically, what makes it a pinning service, right? What are the features for pinning data? And so these would be record tracking and record republishing. So today we're going to be going over the start and stop following endpoint, the delete key endpoint, and the put record endpoints. These are important endpoints in the point of view of someone with access to a local IPFS node. So first, we have the start following endpoint. This is really one of the core features of the IPNS pinning service because it enables the users to have their data available when they go offline, as well as helping others find the content much quicker. What will happen is they send their IPNS key ID, which is identified by this K51 value, and then that will tell our remote node to track their record. And so our node resolves the key and now will be a host of the data, and now it will be available when it goes offline, when the user goes offline, sorry. And so behind the scenes, what we do is we add the key to a queue, to the back of a queue, and then it continues to rotate the keys as it resolves them from front to back. And then after it gets to the front, it resolves the key and moves it back to the back of the queue. So it can be resolved again at a later time. This enables that tracking feature. There can be updates done to the record at any point in between. And so this is just to check on any updates, is it still valid, etc. Now, when you no longer want our node to continue tracking your data, your record, that is when you'll tell the server to delete the key out of the queue. And so what will happen behind the scenes is when you send it over, we will search the queue, find the key if it's there, and then adjust the queue accordingly. Sometimes users just want to handle republishing their content on their own, but that could get cumbersome when they have to think about the electricity costs, needing to go offline every once in a while, or even their own server costs. So one solution is giving your content to someone else to handle the republishing. To do that, we have an endpoint called put record, which works similar to post record. We did post record in another video. I'll link that video in the description below. But the goal of either endpoint is to allow for the remote node to handle republishing for you. Post record is for publishing brand new records through our remote node. But put record is for transferring an existing record to our remote node. Not only that, but the post record endpoint accepts the CID and the private key file, whereas the put record endpoint accepts the IPNS key ID and then the key itself. Not only that, post record works as intended, but put record is still currently under development. Why? Well, I'll go over that in a second. So if I wanted to demo how put record works in this instance, I would have to publish content to IPFS on a different node other than my own, then execute the curl command to send it over to our node. So what's supposed to happen with this endpoint is it accepts the provided key and the provided record and imports the key to our node so that it can handle republishing automatically. But this is not enough for the node to know that it is meant to do the republishing. The node would have to be the original publisher to be able to automatically publish the record. Along with that comes extra problems that may arise that I don't want to get into this video, but I encourage you to look at the GitHub issues that I have online and engage with me there. At some later point down in the road, with either republishing option, you may no longer want the remote node to republish for you. So that's when you can delete the key through the delete key endpoint. And this will also have the side effect of eventually deleting the content off the remote node. I say eventually because if the node is no longer the host of the data, then the garbage collector will clean out that data, and the record would also now be found on our node's distributed hash table. And that's it. Thank you so much for watching. In conclusion, I described and showed the current state of the key pinning features in Fierro API. The ability to pin IPNS records to a remote node will allow users to keep their data available when they go offline and assist with quicker content discovery. Again, thank you so much for watching. Remember to give our repo a star, participate in the discussions and issues to contribute to this wonderful tool that we, the IPFS community, really need. There's a lot of work going on, and I am looking for contributors and people to work with to help develop this out more. And so if you're interested, you can find me on Twitter and Discord at Legend of Mar, or email me at marco@fierrolabs.com. Thank you.